With a focus on data modernization, the Tech Talk series provides an opportunity to connect with our experts, exchange and share information, and integrate solutions to help better connect, analyze, share, and leverage your data. I'm Janell Kochevar, and I lead our user experience research and design team here at RTI. So thanks so much for joining us today. Data is the backbone of everything our government agencies do at the federal, state, and local levels. And that's why it's crucial to make sure that it's accessible, intuitive to use, and visually engaging. Because when data is easy to understand, it helps us make smart decisions and shape policies and plan future research. So how can digital tools like dashboards, data stories, interactive maps help turn complex data into clear, actionable insights? And how can we leverage user-centered design principles to make sure that we're actually including real people in the design process, understanding their needs, and creating simple, intuitive tools that work well? All right, next slide. Thanks, Lisa. So today we have 4 experts from RTI who will share 4 very different products that they've developed. And these products focus on intuitive interfaces and real-time, customizable, interactive data visualizations to make information truly useful. So first, I have the pleasure of introducing Dr. Lisa Lines. Lisa directs the RTI Rarity Project, which uses supervised machine learning to create local social inequity scores for area-level health measures. Lisa?
Thanks so much, and thank you for being here, audience. We're really excited to share some of the things that we've been working on. I know that this project's actually been featured on prior Tech Talks, but we're going to do a little bit of a different spin today. I've just got 4 background slides for you to tell you a little bit about RTI Rarity if you haven't heard about it before, and to give you a little bit of a sense of what you're going to be looking at when we do the data visualization live demonstration. So the RTI Rarity Project, I've been lucky enough to been directing this project since 2019. And it's an internally funded project, an investment that we've made in order to pull together a large data library of validated, research-ready social drivers of health data. We've used the Healthy People 2020 framework, which is shown in the circles that are filled there, healthcare, education, economic stability, and so on. And we've actually expanded those 5 domains into 16 domains, and some of those are actually shown around the outside. And the reason we did this was to try to get much more granular about the data that we were talking about and that we were visualizing. We brought together data from all over the federal government and the public sector, including universities and foundations, to try to get more granular data on what might be actually driving some of these outcomes that we're looking at across the health practice area and actually across other practice areas as well. So even though I've got outcomes in the middle and I'm focused on health, we've actually got people in other parts of the RTI who are working in education or in justice, and they're looking at justice outcomes or education outcomes or environmental outcomes. So there are all kinds of different outcomes that we can use these data to predict and explore. I'm going to skip over this particular slide just to mention that this data is available to all of RTI internally. And how we create the scores that we develop with the data. We start with our conceptual model, which I showed you, and we curate a large database, lots of different measures across different years and different vintages, different geographic units, and harmonize everything, make sure that it's ready to go. And then we use artificial intelligence / machine-enabled learning to model and predict various outcomes. We generate rank percentile scores and conduct validation. These are some of the scores that we have. 4 of them are kind of publicly available right now. A 5th is in development and sort of preliminarily released, and we have more to come. But this is what we've got so far: life expectancy at birth, cancer mortality, sexual and reproductive health, which is actually a composite outcome of 5 different health outcomes there, drug overdose mortality, and excess mortality during the COVID-19 pandemic, the first 3 years. So I'm going to switch now, or actually before I switch over to the live demo, just to give you a sense of what our scores are doing in terms of explaining variance in these outcomes. Our scores, the LSI scores, are shown along the bottom there, and the ADI, the Area Deprivation Index, the SDI, the Social Deprivation Index, and the SVI, Social Vulnerability Index, are three commonly available composite social determinants of health indices that we benchmark our own work against to see, how do we do against these sort of gold standard, quote unquote, social determinants measures. And as you can see, across lots of different outcomes, our models perform very well. The combination of better data and better methods in terms of using non-parametric machine-enabled learning methodologies really does give us an extra boost in terms of being able to explain various health outcomes. So now I will actually go over to the rtirarity.io dashboard, which is publicly available at rtirarity.io. And here we are, the splash screen. And what we have loaded, and what's actually in my background picture here, is the LSI-LE. So this is the model that predicts local social inequity in life expectancy. And when you first reach the dashboard, you're able to actually go to a particular location. And I'm actually going to go to Los Angeles because that is where I currently live. And so if you put in Los Angeles up there, sometimes, yep. So then it just gives you a little drop down and shows you, and then you can go directly to Los Angeles or wherever you want to go. And if you want to, you can actually take off the layer so you can go to a particular place. So I'm actually going to use the zoom function to come down here to the port area. So I actually live in Long Beach, California. And just to give you a sense of what these scores look like when we zoom in like this, you can actually see tract by tract. These are census tracts. And you can click on, a particular census tract and see, what county it's in and actually the quartile of risk or the quantile of risk. And you can see sometimes we have the highest risk quantiles very close in area to some of the lower risk quantiles. And this happens a lot in the US, sometimes just block to block. You can see a real big difference. The other thing I wanted to show on this is the community information. So you can actually look at urban rural, you can look at the social capital index, the child opportunity index, and you can overlay the locations of specific things. So if I actually wanted to look at local social inequity and drug overdose, let me zoom out a little bit. So the LA area is not the most exciting area for that. But you can see up here, there are some areas that are north of the Bay Area where we have very high risk in terms of Lake County there. And if we overlay the substance use services, we can see there are parts of that area, that really high risk area, where there are no substance use providers. Whereas, some of the lower risk areas have tons of providers. And as we zoom out, we can see the same thing showing up here, where large parts of these very high risk areas where maybe there aren't a lot of people, but there's still a high need, and they would have to drive for miles and miles to get to the closest substance use provider. So that's an example of how you can use the LSI dashboard at rtirarity.io. And I'm now going to switch over to a different dashboard just to show you another example of how we have been working on this kind of, interactive visualization. When we do, machine-enabled learning, artificial intelligence, we try to aim for a visualization that's actually going to unpack the model for people, because we want a transparent box. We don't want a black box, And here in our model of cumulative excess mortality per 100,000 people during the first full 3 years of the COVID-19 pandemic, we can see here on this dashboard that we've got a map of the COVID-19 excess mortality rates per 100,000 people, and they're done in quartiles again. And you can see there are little blue places in almost every state. Those blue places actually represent excess mortality less than 0. And what that means is there were fewer deaths during that COVID-19 era than would have been expected based on prior historical patterns. And what we found out about these blue zones is actually, we were wondering, what kinds of things were going on in those places where they had, lower mortality than would have been expected based on historical patterns. And what we found out is that the average population density in these blue zones is only 70 people per square mile. And everywhere else in the country where you don't see the blue zones, the average is over 5,000 people per square mile. So it's population density really that was driving these blue zones in this particular incident, in this part of the what we're looking at. I'm going to show you one other thing here, and that's how to compare the county level means for the top predictors. We put this together based on the feedback from one of our early user testers, and what she wanted to be able to do was actually compare, counties with each other, and being able to look at, a place like here in Texas where you've got, I'm going to turn that little checkbox on, and you've got this little area here, which is a blue zone, and then you have an area over in Central Texas, Brewster County, with quite a bit of a different population level rate of excess mortality. So when we click on those two counties, we get this comparison. We can actually look at the population in 2020 and see how that compares. And then we can see how the rates compare and how our predicted rates compare. Also, some of the top predictors and what are the differences that we see in terms of, why we might be seeing such a way higher rate in some populations in some areas than in others. So I mentioned that we really are trying to explore the map and also dig deeper and allow people to really dig into the causes. And so we actually have grouped the information. We have data drawn from more than 40 publicly available sources. We've got our outcome listed here. We have 189 variables in this model. And we explain that we validated against the other indices that are out there. And if you look here on this graph here, the point of this graph is to explain that while everyone talked during the pandemic about demographics, age, sex, race, ethnicity, and crowded housing, for example, those were the least important domains in terms of the accuracy of the model that we have. And what that means is that, the pandemic's impact in terms of cumulative excess mortality was explainable more by other factors than demographics and housing. It was explained largely by policy and, sort of background level illness burden, as well as community well-being, healthcare, availability of healthcare, the healthcare system pre-COVID, and then food. And so these were all much more important to excess mortality during COVID than the actual COVID transmission itself. So I'll stop there. That's just a quick and very speedy tour through a couple of interactive visualizations that we've built as part of this project, and would love to talk further with any of the audience if you're interested in learning more. Thanks. I'll turn it over to the next presenter.
All right. Thanks, Lisa. We're going to switch gears a bit and hear from my dear colleague, Patrick Brown. Patrick is the technical director for the Department of Education's College Scorecard, which provides national data on college costs, graduation rates, debt levels, and post-college earnings to help students make informed choices about attending college. So take it away, Patrick.
Thanks, Janell. So the College Scorecard. The data set for the scorecard is unique in that it is a merged data set from several sources that has continued to grow for about 10 years. You've guessed it, it's really large. Students, parents, teachers, counselors, and all kinds of people access this data set to make decisions about their college options. We like to say to help them find the right fit. Here at RTI, we use user-centered design and plenty of iterative development to create a tool that is useful to a broad number of audiences, and we're still continuing to iterate. Here's a slide with a little project background on the scorecard. The scorecard comes out of the Department of Education's Office of Planning, Evaluation, and Policy Development. And the first MVP of the tool was released in 2015, and it has gone through several iterations since then. Currently, we have around 100,000 unique visitors a month, which is not too shabby when you consider it's a Department of Education website related to post-secondary education data. The big bonus, at least from what I've heard when doing outreach, is that this is a free resource. I remember, not to age myself too much, but I needed to find a book to do this kind of research when I was looking for schools, and that book I found was probably 10 years out of date. myself in developing the tool, I actually surprised myself with some different options that I wasn't even aware of as an adult. And we'll go to the next slide, please. As I mentioned, this is a merged data set, and you can see here the various sources that are combined with IPED's data, including data about financial aid, student loan, and earnings. It should be noted that this data set is limited only to those who have received federal student aid. Next slide. All right, so a little description of our application. It consists of two parts, an API to store and serve the data set, and a website for our consumers. The API is publicly available, and the website calls the API just as any third-party developer might. Here at RTI, we definitely like to test the edge cases of Microsoft Excel with over 3,000 columns in the main institution files. This encompasses 27 years of post-secondary education and related data. Perhaps you are starting to get a sense of our problem here. It's a lot of data to sit through. Enter the consumer website. The website shows the most recent data available for a select number of important metrics and offers a plethora of ways to search, filter, and sort these institutions that are within the scorecard universe, which is about 5,500 schools. What makes the cut for the consumer site? How do you take all that robust data and make it available to non-researchers? The answer is by asking your target audience, hey, what do you want to see? In other words, user testing. Next slide. Here we arrive at the age-old question of web development. If you build it, will they come? And the answer is, I think they will if they find it useful. My favorite example of this is Craigslist, and I hope there's nobody that works on Craigslist on the line, but it's a terrible looking site and it hasn't really ever been updated. Yet people still use it to this day to sell things, find jobs, and find housing. Now, there might be some better options, but I did just check before this presentation, and yes, people are still posted to Craigslist. Our team is really thankful that the Department of Education continues to prioritize user testing for the scorecard. My colleagues can back me up on this. Any proposed change, no matter how small, is usually met with a, let's user test this. User testing comes in a bunch of different formats. There can be moderated tests like focus groups, review panels, or interviews, and there can be unmoderated tests like card sorting, which aims to help organize site content and navigation, online surveys, or even first click tests. I tend to throw in a third type, which I call passive testing, and that's really analytics. So we use analytics to see how people are interacting with the scorecard, and then we can use that data to make informed decisions based on prior actions. You can see here on the right that we have a lot of different populations for the scorecard. The trick we use to keep those straight is user personas. Fake people we give a name to, a personality, and define their ultimate goal for what they need to get out of the scorecard. And if we advance to the next slide, here's an example persona for a counselor. You can see we define a personality, and then we ask ourselves, what would it take for Paul, feeling the way he does about the scorecard, meet his goal to support high school students? The beauty of the persona is it also defines our segment to user test. Here at RTI, our mission is to improve the human condition by turning knowledge into practice. Science is our core, and what I love is how user testing aligns with the scientific method that we all know and value. Since we're talking to counselors, we can take a stab at coming up with functionality we think would benefit them, which is our hypothesis. And then we can put those wireframes and mockups in front of them and ask, do you find this helpful? Does this make your life easier? In other words, that's the experiment. We know Paul is going to support high school students. There's only one Paul, and we know now, especially these days, there's many, many, many students to help. To help him out, we developed this share feature on the compare page. Paul can essentially build a list of schools he thinks a student may be interested in. With the click of a button, he can generate a link to send to the student. The student clicks the link and then is taken back to that compare page with the institutions Paul selected, and they can review his suggestions. The next 3 slides are some screenshots and videos of the website, and as they're playing, I'll point out a few alterations we've made along the way based on input from user testing. Next slide. All right, here is a screenshot of our homepage. I'll point out the school name search, which is front and center. We made this choice after we noticed during some moderated tests that this seemed to be the most used search option. And then we also backed this up with a review of our analytics. Previously, it had been hidden under one of the accordions below. Speaking of those accordions, you can see we provide many ways to filter and narrow down your search to help find the right fit. The order of the remaining accordions below the name search isn't random either. We also looked at those historical analytics and combined that with what we learned from our unmoderated tests on what people found most important, and that's what determined those orders. Next slide, please. And this one is a video. It's going to scroll pretty fast because we have a pretty long page, but the Wolverines on the line today will probably appreciate this one. The data, as you can see, is divided up into sections like debt and earnings, demographics, allowing users to jump right to what they're looking for. You can see on the page that we make use of a lot of data visualizations, but we also show things as plain text values and tables, as this was feedback we learned from user testing in terms of making sure things were accessible. One of my favorite user testing stories from the scorecard is our midpoint line, and it's just hanging off there. Perfect. When the site was first created, we were showing averages across the scorecard universe for certain metrics like average annual cost or graduation rate. Over time, analysis showed that outliers were impacting these averages in a negative way, so the Department of Education decided to use medians instead. Well, for those of us familiar with data, we all know probably what a median is, but how about an 11th grader? They definitely understood the term average. It's a common term, you hear it all the time, but when it comes to median, not so much. When we user tested this using both moderated and unmoderated tests, we learned that it was easier for our target audiences to understand the word midpoint over median. So that's what we're now using. All right, next slide. Thank you. This is our compare page. And this is my last example, but this entire page was actually an outcome from user testing. We already know how much data there is in the data set. We know that the consumer site narrows that down a lot, but there's still a whole lot to look at. It can be really easy to get confused, and we heard from users, we want to be able to look at this side by side so we can find the right fit. So we created the compare page, which allows users to compare up to 10 institutions and 10 fields of study. This allows them to do exactly what they asked for, see things side by side, I guess technically top to bottom. So in closing, data visualization, plain language, and pretty user interfaces all help make data accessible, but the question really is it the data people will find most helpful? Will it make their lives easier? We believe user testing is so important. How do you know what people want if you don't ask them? There are lots of factors that come into play when creating a product. However, skipping over a user's point of view altogether is never going to result in a product that's a joy to use. I encourage everybody to go check out the college scorecard and play around, so you can find your own right fits. And with that, I will turn it back to Janell.
Thank you, Patrick. Great to hear about how the team has incorporated user testing to really inform those ongoing updates and enhancements to College Scorecard. Thanks again. Right. Next, I'm going to turn it over to Dr. David Birchfield, who is a Director of Technology and Data Management at RTI. David is going to share with us about a dashboard developed for the National Science Foundation to help support their goal of broadening participation in STEM. David?
Great. Thanks, Janell. And thanks, everyone. Really excited to have the opportunity to share this work with you. I think you'll hear a lot of common themes that Patrick and Lisa have talked about, and I hope that that rings true. And with that, we'll share this work. So this is a project that we developed for the National Science Foundation. It's called the Research Community Dashboard. And the goal of this project was to provide internal staff with a number of visualizations and interactive tools so they could better understand the underrepresented groups that are present across the entire range of the NSF portfolio. One thing to note is that what I'll be sharing here is an internal dashboard. So the data that you see on these slides is simulated for the presentation, not the actual data. That's restricted to access. But still, everything that you see here is true in terms of the design and the intention behind the dashboard. So as others have talked about, human-centered design was really key to our process. Early in this, we conducted a number of interviews with users across the organization, really trying to understand what are the types of tools that those users are using today, what types of needs do they have for the future, what would really be the value proposition for this kind of dashboard in the context of other work that they do. Here you see a range of 4 different personas that emerge from that process. And you'll hear me referring to a DESH. So a DESH is the person that really resonated as our key user, a strategic leader within the organization. And we use this to inform all of the design decisions that we made throughout the process. So again, there were 3 primary goals for the dashboard, and this is with a DESH in mind. He is as our target user. So the first is to support strategic leaders with a range of visualizations and interactive tools to broaden their understanding of participation in NSF programs. The second is to enable deep dive questions and investigations. So not just to present data, but to provide tools that they could use to go further. And the third is to integrate other data across a range of sources to align to the NSF portfolio. So you see some examples of that at the bottom. We integrated IPEDS data that we just heard about, survey of doctoral recipients, as well as census data. And I'll give some examples of that as we go through. So what I'd like to do now is I'll walk through kind of the high-level organization of the dashboard. And there are 3 primary sections. So the first one is around proposal flow. So for users like a DESH, they're looking to understand how is funding flowing from submitted proposals to the agency into awards back to the PIs and institutions and regions that have submitted those proposals. Now, one of the things that we really focused on was structuring a user experience whereby a user could get acquainted with the key context and the kind of metrics they'd be looking at before they moved into the more advanced kinds of visualization tools. So each of the sections contains an overview. These are, again, essentially context-setting kinds of visualizations that raise the key issues. Then there's a trend section which looks at data over time for the variables of interest. And then lastly, in this section, there's an explore capability with a number of custom settings where a DESH can really go deep into investigations. And I'll talk more about these as we go. So the second organizing section is participation. So what are the participation patterns and where are the opportunities to engage PIs and institutions, in this case, particularly those that are perhaps underrepresented in the NSF portfolio? So again, as before, there's a context section with a set of graphics and visualizations that allow an entry point into this discussion. Then trend section looking at data over time. And again, another explore section, which has a lot of capability to go further into the investigation. The third is indicators. So what are the factors and benchmarks that reveal NSF submission and funding patterns from an equity perspective? Here again, we've got a set of visualizations that provide an overview of the relevant issues. Trends, in this case, we're looking at trends in the national context using census data that I'll talk about in a moment. And then lastly, a really data-rich environment to be able to explore a full set of indicators, somewhat along the lines of what Lisa was describing in the other related project. Okay, so for us in designing this, we really wanted to be able to answer this question. Why visit this dashboard? What's the value for those internal users? And principally, we wanted to be able to have a way for these users to engage with key and emerging topics for the NSF. And what I'll do now is walk through some examples of what that looks like. So on the one hand, users like a DESH really want to be able to take a holistic view of the portfolio and look for outliers. So what you see in this graphic, each of the dots on the chart represents an institution that has submitted proposals to the National Science Foundation, and then a trend line in the middle that compares the submissions against awards to give a funding rate overall. And here you can see some trends. So this XYX university has a funding rate of 41%, well above the typical funding rate, whereas this institution, State College ABC, is down at just 17%. So here, this is a starting point for a DESH to be able to go further to understand what are the patterns behind these outliers and what might they be able to do to mitigate issues that they're seeing. Another key questions for users is to look at intersectionality. So what you see here charted over the course of years is the number of proposals that were submitted by investigators that are Hispanic. Now that's one way of looking at these data, but importantly, what we're doing is to overlay gender, and race ethnicity. So here in the blue, you see the count by Hispanic female researchers, Hispanic male researchers, and so on. So importantly, we're not looking at these characteristics necessarily in isolation, but helping users like Adesh to see the intersectionalities between them. Another key topic is looking for gaps and opportunities. One thing that we recognized early on is that if the NSF is only looking at their own administrative data, they're missing the full picture of those institutions and researchers that are not participating in their programs. So what you see here is a rendering. The counts in green are showing by institution type the count of institutions that have submitted proposals to the NSF. But over on the left, equally as important is what are the counts of, for example, public four-year institutions that have not submitted proposals. Here we're trying to identify opportunities for Adesh to say, who else could we go and interact with to try and engage more fully with the NSF? I talked about this a little bit earlier, but this is an example where we're looking at the distribution of different demographic trends, so changes in population for each state across the US. We're looking at the background color for each state indicates the change in the percentage of the population in a given state. And then overlaid, we're looking at the change in the percentage of proposals submitted by PIs that share that same characteristic from the state. Let me give you an example. So again, this is not real data, but looking at the state of Maine, for example, we see a discrepancy. There's a change in the Hispanic population where it's increased by 1% over that 10-year period, whereas the count of PI proposals submitted by PIs with that same characteristic has declined. So here again, it's asking the question for Adesh, what might be driving that discrepancy? Where's the NSF leading or trailing these broader national trends? Just two more examples here. So looking at here we're looking at the flow of proposals and awards from, in this case, looking at the distinction between institution in rural locales compared to city or suburban locations. So what you see, the height of the bars in this Sankey chart are showing, for example, the proposal count. So a tall bar means that the proposal count is high coming into a particular division or directorate within the NSF. And then flowing out to the right side, a smaller proportion. So the awards going back out to that same locale. So in a case like this, it's a way for Adesh to visually really see any kinds of disproportionate patterns in those award and submission rates. And lastly, I think this is the one that is similar in terms of developing a model looking specifically at access indicators, so measures of equity in participation by PIs and institutions in the NSF programs. So here we've identified over 40 demographics, institutional and geographic indicators of diversity. And importantly, Adesh is not locked into one particular model, rather can select from those different indicators to create customized reports and generate an overall score at the agency, the directorate, or the division level. With that, I'll pass it on to the next speaker. Thank you.
Thanks, David. And thanks for sharing about this complex tool. It's a really unique approach that gives key stakeholders at the NSF a way to visualize their data and analyze trends and make informed funding decisions. So thanks very much. Okay, last but certainly not least, it's my pleasure to introduce Dr. Darigg Brown, who's a behavioral scientist leading research focusing on substance use, HIV/AIDS prevention, mental health, positive youth development, and health equity. Darigg, it's wonderful to have you with us. I'll turn it over to you now to share about the Georgia Prevention Data Hub.
Thank you very much, Janell. Can we back up one slide, please? There we go. All right. So thanks again, Janell. Hello, everyone. Pleasure to be here with you all and to share this opportunity with my fellow panelists. So in 2022, RTI was commissioned by the Georgia Department of Behavioral Health and Developmental Disabilities to create the Georgia Prevention Data Hub, which is a comprehensive interactive online resource that brings together in one place different resources on and substance use data specific to Georgia and its communities. With the Prevention Hub, we capture current data for substance use and various co-occurring conditions, along with risk and protective factors. It includes robust data visualizations and a catalog of educational resources. The goals of the Prevention Hub are to increase systematic communication on behavioral health data, provide increased resources for prevention, treatment, and referrals, enhance the usability of data such that it becomes a primary community resource site, and to improve interagency collaboration and real-time appropriate responses. Next slide. The Prevention Hub is a centralized location where prevention practitioners, researchers, parents, and community members can find resources curated from around the web. We employed a user-centered design approach to guide the design of the site and the curation of the training, media, prevention, treatment, and wellness resources. One of the spokes connected to the Prevention Hub is the Georgia Strategic Prevention System Data Warehouse, which is an existing online site that holds a lot of the state's data and visualizations. I'll be focusing on this part of the Prevention Hub today. Next slide. This slide outlines our initial phase of developing the Prevention Hub. Here's a brief overview of the 4 main components involved in gathering and synthesizing data. I won't be able to go through each of these components during the presentation, but this gives you some perspective on the process we use to build the Prevention Hub. Next slide. As I mentioned earlier, the data warehouse is one of the main components that is linked directly to the hub. We completely recreated the data warehouse to make it more nimble and user-friendly, to make it easier to access and capture data, and to make it more aesthetically pleasing. It contains a wealth of reports, publications, and newly created interactive dashboards that display substance use, mental health, and suicide data. Next slide. Our goal during this first iteration of visualizations was to make at least 25 data sets available to the public, because we understand that finding, using, and comparing data can be very difficult at times. Having partnered with the state of Georgia on other efforts over the years, we've heard this loud and clear from local providers, grantees, and other stakeholders across the state who have needed to access behavioral health and substance use data. In making these data sets public, we also wanted to create a process to efficiently collect, visualize, and share the data sets, with an eye toward keeping content up to date and automating the updating process and simplifying content creation using standardized tools for visualization. Next slide. So we chose to use Tableau as our data visualization platform. For anyone who's used Tableau before, you know that it has several advantages. It is rather user-friendly. It allows you to interact a little bit easier with your visualization. You can simply mouse over different pieces of the data to show additional information. There's not a whole lot of coding required when using Tableau. But once your visualizations are created, it's fairly easy to embed them within a dashboard on a website. And there are some other pretty attractive standard visualization options in Tableau. Next slide. But as you can imagine, Tableau also has its drawbacks and limitations. There are a couple of versions of Tableau, Tableau Public and Tableau Cloud. Tableau Public is a free version, allows for public dashboard hosting and can make data publicly accessible. Tableau Cloud, on the other hand, is more of a private dashboarding option. There can be some, well, it requires a higher level of data security, and it is definitely more expensive than Tableau Public. In using these, unless you're expert at using Tableau, there is quite a learning curve. Fortunately, I was able to partner with some of our colleagues in the analytics practice area and the Center for Data Science on using Tableau. And there are also some limited visualization types available in Tableau, a little more limited perhaps than maybe some other options. Next slide. So during the creation process, we consulted regularly with our colleagues at the state and kept in mind the potential end users and any potential use cases, such as the need to better understand the unique contexts of different communities and the factors that create the health challenges they face. Also, undoubtedly, many individuals and organizations are looking to use data to influence research or policy and to generate continued support for their initiatives. Next slide. We also structured the site such that users can search and cross-reference data across multiple categories, such as indicator, that is substance abuse, mental health, or suicide, by geography, and also by demographic. And they can search for a single year of data, or they can search across multiple years to produce data visualizations. Next slide. So here we come to the brief demo portion, I guess, of this part of the presentation. Let's say you're an elected official based in Fulton County, Georgia, which is an actual county in Georgia, and you want to understand the impact of opioids on your constituency so that you can have data to influence public policy. You would navigate to the Strategic Prevention System Data Warehouse. You'd narrow in on the substance abuse prevention data category on the right under Find Data. Then you'd select interactive dashboards. That's what you want to produce. And you might select the opioids tag if you're looking specifically at opioids. From that, you would get a list of dashboards that are available. You can see several options here, such as the Georgia Student Health Survey. This survey is an annual survey that every school in the state of Georgia is required to administer to their students. And the survey is held by the state's Department of Education. So select the Georgia Student Health Survey. Next slide. At the top, you can see that we're looking at a single year view of data. For these purposes, we've selected the year 2022, and we're looking at painkillers, the use of painkillers for all grades and all genders. You can also toggle between having a demographics view, a trends view, a demographics trends view, and a view according to health behavior. So there's several different views and ways you can manipulate the data once you're inside the warehouse system. Next slide. So here is the output from those selections. This output shows that about 14,000 out of 386,000 individuals, or 3.7% of students captured in the Georgia Student Health Survey statewide, reported using painkillers in the past 30 days. Next slide. If you mouse over any county in the state, you pick a particular county on that map, you can see how students in that county compare to those across the rest of the state. So in this case, we selected Fulton County, and you see the information displayed on the right for that county. There is a higher reported use of painkillers in the past 30 days in Fulton County compared with students across the rest of the state. Next slide. We can also toggle to see a trends view of the dashboard, as I mentioned earlier. Here we can see that reported painkiller use over the past 30 days actually increased, and it has been increasing, I should say, over the past several years in Georgia. Next slide. And again, still looking at the trends view, we can compare these data for any specific county. In this case, we chose Fulton County again, and we can see a similar trend in that county. The increase in painkiller use over the past 30 days for the past several years. So there are many other types of trends and reports and visualizations that you can create using the tools embedded in the Georgia Data Warehouse. You can search by any of the indicators mentioned or by reports, presentations, or other documents contained on the site. This is just one tool or module of the overall Georgia Prevention Data Hub. There are many others, and we hope to continue partnering with Georgia to further develop the hub and bring in additional, more current data to not only make it a premier resource for users in the state, but also so it can serve as a model for other states who wish to create a repository that connects users seamlessly to different data sources and the resources they need to tell their community's prevention story. Thank you very much, and I'll turn it back over to Janell.
All right. Thanks, Darigg. Before we jump into our Q&A session, please note that all registered attendees will receive an email in the next few days with links to view the recording and download the slides from today's presentation. And you can see contact information for each of our presenters there on the screen. So we have some time remaining to answer a few questions that have been submitted through the Q&A. We're going to start with this first one, I think, which, Patrick, would be great for you to answer. When deciding what type of dashboard to create, what are the questions that you ask about the end users?
Sure. Thanks, Janelle. So my first question usually is the dashboard actually appropriate here? I'm a really strong believer in having good context around your data. When it comes to dashboards, sometimes it can be overwhelming. So that's the first question. If your users are familiar with the data, you're probably good to go with a dashboard. If they aren't, you might want to consider a data story, which adds that additional context. Then the next question I get to is around data security and privacy. Is that protected data? Who can see it? How protected does it need to be? As David kind of pointed out, there's internal products and you need to kind of be thoughtful about what that data shows. And then after that, if we are all clear, we can get into our audiences. So how are people going to be accessing it? Who? Is it the general public? Are there organizational users that are accessing it? Is it going to be from phones or from desktop computers? That's a big consideration. And then something that I learned along the way here at RTI is internet access. We do a lot of work around the world, and sometimes in African countries, for example, internet isn't a guarantee. So, do you need to streamline things to make sure that everybody can access it? And then probably the last question I would ask is performance. Does it need to be a dashboard that is updated every second? Does it need to be updated daily? Is it something that users would be fine setting a bunch of fields and running a report and getting it in a minute? So those are all the considerations that I kind of would start with when asking about the audience for a particular dashboard.
Awesome. Thanks, Patrick. Yeah, and just to underscore what you said, we try to learn as much information about the user's context and what they're trying to learn from the data to really inform and shape that solution. Okay. The next question that we have here asks, how can we integrate these types of data visualizations into materials for policymakers and the public? And let's see. David, do you want to field this one?
Yeah, sure. Happy to. It's a great question. And I think that, one of the things that we really tried to work through in the NSF dashboard that we shared was trying to balance the a number of sophisticated tools that would allow a user to go into a deep investigation of a particular topic, which is powerful. But those tools also require a fair amount of expertise. And so to balance that with these kind of contextual, more kind of straightforward presentations of data, and to design a user experience that would allow a user to move through that kind of a progression. So in some sense, they're prepared to take advantage of the more powerful interactive tools. And I think that same kind of an approach applies here, where you've got, policymakers are certainly strategic leaders thinking about the implications, and they need the access to conduct some of these deep dive investigations on their own, and then to go further with that. And I hope that kind of an approach to a user experience that we worked on for the dashboard might apply in some of those situations as well.
Yeah, definitely. Thanks, David. And I just acknowledge, policymakers in particular are very busy people and experiencing just a deluge of information, I think, like most of us are. So I think, we have to keep information clear. We have to be able to get straight to the point, make sure that we're using plain language, and really pulling those main points into the visualizations so that it's easy for them to get what they need immediately. Okay, let's see. We have a couple more questions in here. This question asks about the application of journey mapping in the design process. So for those who aren't familiar, journey maps are kind of a visual representation of maybe a sequence of interactions that a person has when they're using a product. And journey maps are helpful for a design team to really understand kind of the full complexity of the experience, identify a person's pain points so that we can prioritize their needs effectively. Lisa or others, do you want to kind of add to that?
Yeah, definitely. I think the thing that we have to have a lot of when we're kind of developing these kinds of complex dashboards, we have to have empathy for our end users. We have to understand where they're coming from, put ourselves in their shoes, and not just assume that the way that we do things is the way that our users are going to do things. I often test various things with my parents because they are older, and if I want older adults to be able to navigate the dashboards that I'm putting together, I'm going to start with my parents because they're free. I can user test on them all day long. But yeah, I think, getting no stories without data, no data without stories, to sort of tie all of that together. I mean, really, we have to understand the stories of our users, understand where they're coming from, and be flexible in our approach so that we don't just, use something that is, one size fits all. It really is, almost every dashboard is going to be very, very tailored to a specific audience. We have to know our audience who's going to be using it.
That's great. Thanks, Lisa. One more question here. Has RTI come up with a uniform approach to attribution, or do you leave this to each of your clients? Kind of open this up and see if anyone wants to take a stab at this.
I'll take an initial stab and folks can join in. I would say at RTI, we don't do anything uniform, or we try to meet our clients where they're at. So it really depends. We don't have a firm line on doing anything in any particular way. So we really rely on what our client would like to see from us. And then we work with them to make that happen.
That's great. Thanks, Patrick. So I think we're going to wrap up here today. I want to thank all of our presenters and all of the participants who've joined us today. As a reminder, today's presentation was the 9th in RTI International's Tech Talk series focused on data modernization solutions. Please check out rti.org for more information and to register for upcoming webinars. So thanks so much for joining us today.